Blog Talk Radio.
Welcome to the Kentucky Water Fuel Museum webcast. The date is March 24th, and we have a very special guest tonight. It is Stephen Meyer, twin brother to the more commonly known water fuel inventor Stanley Meyer. And let's see if Stephen isn't with us. Stephen, are you there?
I'm here.
Great. Well, we have 1 hour to cover a tremendous amount of territory because this is the first real public interview that you've ever done. Isn't that true?
That's correct. This is the first one, and I decided to do it on your show. I kind of like what you've done over the years. I've been monitoring different things that you've been doing. You've come a long way, and so I'm here.
Well, I'd like to welcome you and express great appreciation for your willingness to reveal to the world your involvement in the pursuit of clean energy technology over the past, 30 years?
It's been quite some time.
Yeah. Well, why don't we go back in time then and start with your background, because people really don't know who you are and what you've done in the way of inventing, developing products for various industries and government and so on. And so your resume is quite impressive. And why don't we begin with your education? You apparently went to about 3 different universities?
That's correct. Mm-hmm. I went to Ohio State and then Peninsula College in Washington when I was in the service, and then back to Ohio State after the service, and then wound up at Franklin University going to night school, and finally graduated in engineering in 73.
Okay, and that's electrical engineering, correct?
Yeah, electrical electronic engineering, and then I had a minor in business management, industrial management.
Okay, and so the branch of service that you were in, the military service, was the U.S. Air Force? Yes,
it was kind of funny. When Stan and I were in Ohio State right out of high school, Stan went into Air Force ROTC, and I went into the Army ROTC, and then I left after about a year and decided to join the Air Force. I went into the Air Force, and then shortly thereafter, Stan got drafted in the Army.
Isn't that funny?
Yeah, it is.
Branches of service.
And the thing that really got me was that my first squadron commander called me aside one day down in Keesler, Mississippi, and he started talking to me like he knew me, and I said, my gosh, I really don't know you. And he said, sure, you were my student up in Ohio State.
He was confusing the twins.
Yeah, oh yeah. So I told him, I said, no, you must be talking about my brother.
Isn't that funny? That is very funny. Well, I thought it was a funny coincidence what you told me last year about how the two of you were serving in overseas, different branches of service overseas. You were both discharged and arrived at your parents' home at the same time, unbeknownst to each other.
We did. I wasn't overseas, however. I was in the Pacific Northwest, and I was 76 miles from the nearest town, so it could have been overseas.
Yeah.
But the thing was that we both got out of the service, and we showed up at our mom's doorstep exactly on the same day within an hour of each other.
I think identical twins have a lot of funny coincidences like that.
Yeah, it was funny. Stan showed up with his uniform and still had his gun in his hand. I thought that was kind of interesting. He had been up on the DMZ in Korea, and they said, you got to go down and talk to somebody. So he went down there, and they said, get on the plane. And he got on the plane and came back to the States. And so
isn't that hilarious? Still had his gun strapped to his side, huh?
Yeah, well, no, he just had a rifle and some of his camouflage stuff, and he stuck it in the corner for a while and then decided, well, maybe I better take it all back.
Yeah, that's funny. So in the Air Force, you did receive some recognition for your work, did you not?
I did. When I went into the service, I kind of blossomed in the service, and I saw the opportunity, and so they sent me down to a basic electronics school. I had gone down and taken all their exams, and I wanted to be a pilot and a navigator, but found out that I couldn't see and didn't have any glasses, so they let me go into ACNW, which was heavy ground radar. And so I went down to Keesler, Mississippi, and went to what they refer to as basic electronics. And then after that, I got into advanced electronics. And before I left Keesler, I got into tropospheric scatter. And so I was getting a pretty good education with the Air Force, and then went out and worked on the FPS-7 radar set out in the Pacific Northwest. And it was actually a 10 million watt radar set, and we covered the whole Pacific Northwest.
Wow.
And I got involved in ECM, which is electronic countermeasures, and at that time my ratings kept climbing, and I got up to the top 5% of the Air Force when I was there. They really wanted me to stay in, but after 4 years I decided to go back to school.
Okay, and that was a good thing because you were able to pursue studying technology that became useful as you went about your business inventing things.
It did. Well, I had already, when I was in the service there, I had advanced schooling in tropospheric scatter, and then I got involved in taking USAFI courses in the service, and I actually had done my first 2.5 years in the USAFI courses.
What are you referring to? I don't understand that expression.
USAFI is a correspondence course in the military that you get college credits for.
Uh-huh.
And it was very interesting because I got into transistor technology. When I first went into the service, everything was vacuum technology, vacuum tube technology. And the transistor had been invented, and it was just coming into being, so to speak, and the military was getting the first entry into transistor devices. And so we had a couple new pieces of equipment come in. So I went and studied all about how transistors work and the new high-tech devices, if you will. So when I got out of school, I went down to Franklin University, and I called up Dean Kelly on a Saturday, and I went down and I proficiency my first year of college on a Saturday at that point because of my background and what I knew.
So that meant you went into the workplace then, huh?
I'm sorry, what?
Does that mean you went into the workplace at that time?
I'm sorry. Say it again.
Is that you began your civilian career at that time, or?
Oh yeah. I went into in the college at that time. I had actually got out of the service, and I went into Ohio State University, so I went during the day. Then I went to Franklin University at night, and I did that for the first couple semesters, and then I switched to night school in Franklin University. And the point there was I was married, and I had one son, and then I had a daughter coming, so I had to go out and work and then go to school at night. So.
Okay, so you began working in again high technology application of electronic.
Well, yeah, exactly. My first job, after I got back into school, and I was in school for a short time, I'd taken a job repairing television sets for a Conn's jeweler down in Columbus, Ohio, and they had like 250 TV sets up on their third floor that didn't work, and so within 2 weeks or so, maybe 3, I got them all repaired, and they told me not to do any more because they couldn't find the customers. But in any case, I had bumped into a couple fellows that said they had a new company. It was called Ray Data, and I went down there and talked to them. And they had a farmhouse. They just started a company, and so we got together, and I started with them, and then we sat around trying to think out what we're going to do, and they had kind of an idea, but since I had a background with transistor technology and it was brand new, we came up with an idea of doing some building instrumentation for the analysis of rotating machinery. So we applied Fourier analysis, came up with our math models, and constructed and designed our electronics to protect machinery.
Okay, and then I noticed in your resume you mentioned Reliance Electric.
That's right. We were doing really good as Ray Data, and we had built a lot of equipment that monitored electric motors and things of that nature. And Reliance Electric came down and took a look at what we were doing, and so they decided to buy us out, which
so you
they
then
did.
work for them.
So yeah, I came into work on Monday morning, and I found out that I was working for Reliance Electric.
And so you were doing research and development for them and process control designs, is that it?
That's exactly right. We had, our company was really small when we started. We had the kitchen of the farmhouse was sales order engineering, and then the library was the engineering office. Living room was drafting. The basement was research and development, and the garage was a hydraulic lab.
So in other words, all these tinkerers listening to this program shouldn't feel bad about working in their basements or their garages, because even Reliance Electric did that, huh?
Oh, absolutely not. I mean, Reliance Electric was a big company, and we were just a small company, but we had a technology that they recognized, and we had talent, which they recognized. And so that all culminated into building a really nice business. We eventually, they built a manufacturing building in the back, and then we actually moved away from there into a brand new facility as time went on. And we built that business from scratch all the way up to a major player in the marketplace. And then Exxon came along and bought out Reliance Electric. So I found myself working for Exxon for a while.
Isn't that funny?
Yeah.
And then what about Toledo Scale?
Toledo Scale, we actually bought out Toledo Scale. They were in Toledo, Ohio, and it was a company that produced a lot of plants, processing plants, and processes. And so we bought them out and moved them down to Columbus, Ohio, or actually Westerville, Ohio. Then we got involved in doing a lot of batching processing systems. We were designing the electronic and computer process control systems. And the computers were just coming in. I had been working on the T2, the T4 computer in the service, which was already up to 1,096 bits. And they came out with a digital equipment computer that was just starting off in a 16-bit machine. And then they came with some small processors like 4-bit, 8 bits, and then the 16. So we started out very early in the computer game.
Mm-hmm. And then Altec, is that pronounced right? Altec?
Altec was a small venture for me in a way. I had a bunch of friends. Don Cullen was one of my best friends at the time, and Don had worked with us all the way through Ray Data and into the start of Reliance, I believe. And then he broke off and with a fellow, and they started Altec. And then a few years later or so, he offered me a position there, and I took it. And we had just gotten into the laser technology. Don had gotten about 50 patents on the laser, and it was just a toy at that time. People didn't really know what to do with it. And we came up with a triangulation system for measuring thickness of material, and then we developed laser light curtains, if you will, and we did a very simple system. We used what refer to as shadow graphics, where you just shine a light, and if you put your hands between the light and the screen, you see a shadow on the screen. And so because laser is a coherent frequency of one frequency, we were able to adjust the optics where we could measure the diameter of wire, and we could measure the diameter of the dielectric on the wire. Then we used an XY coordinates with that technology, and we actually went into the wire and cable industry and actually helped them during a time when they had a turn down. Housing industry had turned down, and I had these very expensive laser heads. They cost about $6,000 a piece at the time, and we did not think that anybody would buy them because they were so expensive. But I went out to rural New York, and while I was there, I set a system up just to do some testing. I had asked them if I could. A couple of fellows came out, looked what I was doing, and finally there was a couple more come out, and then finally about 4 came out, and they said, "Gee, what does this thing do?" And I said, "Well, I just figured out that you're putting on too much dielectric on your wire." And he says, "Well, we have to do that because it will short out." And I said, "Well, Actually, it's only because the wire is floating inside the coating is why you have to do that. So I said, we can control the wire and make sure it's right in the center of the wire, and then you could cut back on your dielectric. And it turned out to be a 45% savings.
Wow.
And a fellow walked me back to his stock room. He had these big barrels of granular plastic. And he says, you mean to tell me that I don't have to use 45% of this material? I said, that's correct. So I went back, and I was packing up my equipment to go home, and they came out and said, where are you going with our equipment?
Yeah.
So it was kind of funny. I called up Don, and I said, gee, those 2 units I brought out here to do some testing. I said, oh, gosh, I said, they won't let me take them home. And Don says, hey, you got to. I don't have any more. That's our first ones. I said, well, you better build some more.
Isn't that funny?
Yeah. So we started the radiator business, started climbing pretty good. And we took it to, I was there about 2 years, and it really launched pretty good. And then I started my own company, and in electronics and in computerization. I was very familiar now with the industry.
And that's Aplitech?
That's Aplitech, that's
and
correct.
So how long has that been in business?
Well, it's from present all the way back to 81, I guess.
Wow, okay.
Yeah, so it's been a long time.
And so you've noted a number of successes in the endeavors that you've had as far as technology, such things as radar systems for the government, for the Air Force, jet engines.
Did an awful lot of work with jet engines. I had designed with a team of fellows a piece of electronics that at that time they were working with frequency domain on their equipment, and I realized very quickly that the jet engines would not be protected because they accelerate so fast. So I converted everything to a time domain, and I was able to establish electronics that would do a predictive control. And so with just several points of measurement, I could actually predict where the jet was going to go. So we were able to protect it and shut it down, and that was a huge product for us.
Yeah, I think this is an interesting one here that you used in Libya to put out I guess an oil well fire using 2 jet engines to shoot natural gas down in. And
yeah, what we did there was that when I went over to Libya and went out into the field, I went in 800 miles. If you triangulate between Benghazi and Tripoli, about 800 miles, that's where they found the oil. And the field had not been opened up at all, except that they had done some drilling. And what happened was a huge volume of natural gas was released and was being released in the air. And you can't let it go into the air, as raw gas. So they had to light it. And when they did, you could see that son of a gun 25 miles away.
It was 3 miles high, huh?
Yeah, if you look at the curvature of the Earth, for example, if you're looking straight on the Earth's surface out into space, if you go out 300 miles, you're 33,000 feet above the horizon. So if you bring that back to where we were looking at the tip of that, the height of that torch, it was about. It fluctuated between, I'd say, a mile at the low point and about maybe 2.5 or 3 at the high point.
Wow.
And it was unbelievable. So what we did was we got an idea. We said, well, why don't we take the natural gas that's coming up and run jet engines off of it, and then we would take the exhaust from the jet and push a gigantic compressor and push it right back down into the ground. So we did that, and it worked.
What an ingenious solution.
Yeah, so we were able to extinguish that torch. They called it the torch. So then they went in and they built 2 more trains after that, and we actually increased the yield of the oil field by about 10%.
Well, you have a number of other accomplishments listed here on this resume that are very impressive, and someone may be wondering, why have we just used the first 20 minutes of this interview talking about these accomplishments that have nothing to do with water fuel? Well, it's because your involvement in this technology and that of your brother have been called into question by people who really don't know the story, and they've attempted to lump you into a category of alternative energy con men, people who never really had a working product, but who tried to foist it on a gullible public and get investors. And when you type in Stanley Meyer on a word search, this fraud case comes up, and they think that the net result of all of your all's work in alternative energy was some fraud where investors got scammed and sued and won. So I think it's important.
Well, first of all, I have a sterling reputation in the industry.
Absolutely.
Well, the people don't get to be my age and have the successes that I have without that sterling reputation. And the thing is that a lot of people say a lot of things which aren't correct, and you know it's disheartening. Stan's not here to defend himself. And I, for one, look at it and I shrug my shoulders at him. I said, well, boy, it's amazing to me, that. And besides that, the case that I think you're talking about where it's fraud and so forth, Stan Meyer had a contract disagreement, not a technology disagreement. And there's quite a story behind it. But in any case, they basically, the two fellows, one was sick, and the money.
Hello, Kevin here with the video tutorial of the Rustic 7.0. I thought I'd just give a run through of this circuit and clarify anything or any questions that anyone may have about this. Now, let's go over the circuit quickly. Basically, you have one frequency generator here. We have a 555, which creates a high frequency. This chip divides it by 10. This one divides by 10 and divides by 10, which is selected by this switch. So by the time, if you're running a signal off of this last one, you're going to have the slowest signal. That signal just runs through a flip-flop and an LED here, which shows that this circuit is working. That's how the signal is created. The flip-flop creates the 50-50 duty cycle, so all your pulses are half on and half off, just like that. So we have signal generator 1, signal generator 2. We have a follower switch right here, which lets these dividers run off this 555. All the circuitry here is powered by the 7805. 7805 has a 7 volt or greater input. You can see that feeds into the circuit here and here. Now as we run down to the bottom here, signal generator 1 and 2 both run down into the AND gating system. This can be turned on or off with the switch right here. Then on to the output here. We have signal 1 output, which comes off the AND gating, and signal 2 output, which can actually output the first signal, signal 1 signal, and if that makes sense, and also output this one as well. So this one has the option of switching between this and this output, whereas this output only comes off of here, and this one only has the gating function. This signal runs into our TLP chips. It's the white 8-pin chips you see on the board. This chip needs an external 12-volt source to keep it isolated from the rest of the system. So here we have a 7812 chip, which needs a 14-volt or greater input, and that simply just feeds this chip, and then the chip comes out to our IRFP264. I added these markings on the schematic drain and source just to prevent any confusion there. And that's about it for the schematic. Let me show you some things on the circuit board. So here's one of the kits, all completed. Basically you can see here, Signal Gen 1. Here's your multiple speeds. Switch between high and excuse me. Switch between high and low, and this will speed up and slow it down. As you can see. Here's our AND gate switch for gating with the LED here. These two LEDs are just the indicators that the signal gens are working, so there's not much usefulness for these. They're just more to indicate that it's working. So signal 1 components or adjustments here, signal 2 adjustments here. Here you see that single chip to make this other signal gen follow this one. And then we have our output here. You can see signal gen 1 only has 3 wires because you can only put out what's coming from here. Signal 2 output has 5 wires because you're able to switch between here and here. And as well, both of these you're able to invert the signal as well. As for the power source, I'm going to show you as well. This board's also all labeled. I labeled all the numbers, all the wire colors, so I don't think anyone can get confused of what goes where. Here you see the 7805 5-volt regulator. And here's the input right here. Turn on and off, and that simply goes to a no focus there. That's a 9-volt adapter. So we got signal generator 1. The reason I have black and green wires, the black's going to go to ground on the battery or power source, and green's going to go to the load. I'm not going to put any positive into here because this is an NPN transistor. Because here's the 12-volt regulator, which is, like I said, is powering this white TLP 250. Sorry, the focus is kind of off here. So here's that power source. I have an 18-volt adapter on there. Let's plug this in. See? Signal 1 being gated by signal 2. Let's see if I turn this gating switch off. That's only signal 1. Gating on. Also, I've put little black dots to whoever's getting one of these kits, little black dots to mark the top of your switches. It'll make things a little bit easier for you to install. I'm going to shut this off, and there it goes. Move over to the completed box that I have here.
And that's what's happening to this lot of fuel cell.
Take power sources off.
And right now, I am in that same position.
Here is the back of my box.
I think I'm starting to understand what all these inventors.
These only fit in one way, so I can't get them confused.
I'm going to pass it to them.
Here you see, this is like the black and the green coming off the IRFP. The only reason this red connector is here is because I have the meters inside the box, or else those wouldn't be needed. Power switch, let's turn on. This LED is not in the schematics. This is basically just running off the 12-volt regulator with a somewhere about a 500 ohm resistor. I'm going to take this wiring, black and the green. Like I said, we don't really need the red. And this is in the schematic, these switches. It's going to turn the signal on and off. And I think one last thing I'm going to show you is a nice, cool function that Russ showed me about the resonant, maybe called resonant, I don't know, don't quote me on that, of the gating system. So basically what I'm going to do, okay, I'm going to turn gating off, and turn this on, so you can hear that. Now, hopefully I can capture this in the video. Let's try to do this here. Let me get this camera in a better location. There. Alright, so I'm gonna... Let me turn this about here. Now. See, I don't like these resistor pots. You can see there's some couple weird spots in them. Another thing I can suggest is to add a smaller ohm pot in series with this, and that way you can get some fine tuning. So as I'm going to turn gating on, now as I speed the gating up to match just under the frequency of this, we're going to get a really cool function. Where is it? That's why I'm looking at the wrong lights here. Of course, these are just the indicator. That's why I'm getting all confused. This is the actual input that we want to look at. Let's speed this up again. I'm going to bring this to...
Because as time went on, Stan and I talked about things, and we were looking at it, we were learning, talking about things, and we started to get a sense and feel that there was more to this.
Can't really seem to get it to work right now.
This process. We started to see a tremendous amount of energy available. You know, if you go into the, look at the,
anyways, I guess I should cut this video out now, since I'm not really getting the results I want. Maybe I'll post another video later, once I figure out what the problem is. Anyways, thanks for watching. Again, this is the Rustic Frequency Generator 7.0. Hope you enjoy the video. Thanks.
Like perpetual motion, and people use them quite indiscriminately and really in the wrong context. And let me give you a case in point. Perpetual motion. I hear this word perpetual motion. But originally what happened was when they were developing the microscope and they were increasing the magnification, you know, and as all new inventions, the magnification gets better and better and better. And what happened was they were using pollen. And we can't see pollen. It's so small. But they were putting pollen into a drop of water, and when they were doing the magnification, they saw that the pollen was always moving. And so every time they went back, they said, well, it's perpetual motion. It's moving. So they went to Einstein, and so and asked Einstein, says, what's causing the motion? Is it the pollen causing the motion, or is it the water? And so Einstein said, he looked at it and studied it and came back and says, well, the water is what's pushing around the pollen. Well, there was a spinoff from that because Einstein was able to determine the size of the water molecule. So that's the key what perpetual motion is. Now, when you come to over-unity devices, that's another terminology that people definitely are not using correctly. If you look at, if you took a piece of paper and you drew the x-axis and the y-axis and you go down into the lower left-hand corner and you start drawing an exponential curve, if you draw at the very lower corner area, you could draw and say, okay, that's where we look at what I call linear functions of our universe. When you look at what's in motion stays in motion and so forth. With Newton's law, but then again, if you continue on the way up in the exponential curve, you can go up to, let's say, 3-4 inches on the page, and you get to the top of the exponential curve, and that's where Einstein realized and was able to derive from the equations. He is able to derive and determine that E is equal to mc squared. Now, the point in case is that it was Einstein's work with photon energy that he discovered and realized that mass can change into energy, and energy can change back into mass, which is huge amounts of energy. Now, that the energy is locked in every atom, and it is locked in because in the universe you have hydrogen and you have helium in the universe, and then when the stars explode, when a supernova explodes, it actually is so much energy, and the temperature is up in the trillions of degrees. The elements are formed. All of our elements are formed at that time, and when that happens, it stores a huge amount of energy. And so Einstein realized that these atoms have a huge amount of energy. Well, when you look at combustion in an automobile engine, the combustion process only uses 1/millionth of its mass energy. Only 1/millionth of its mass energy. So if you did something, you add these products, the hydrogen and oxygen, to this process of combustion, and you get a little more energy out, all you're doing is basically converting a little more of that mass energy. That's where it's coming from. So when people say you got over unity, they'll realize how much energy those atoms have. So you have valent bond energy, you have ionic bond energy, and you also have a mass change energy that you're dealing with combustion. And
now, am I to understand that as this research on the part of you and your brother went on, it began simply breaking those basic bonds, but you ended up getting into something more like nuclear energy? Is that so?
Well, what happens is you start to cross into areas that all of a sudden you become aware of, and you can go back and you look at Stan's process, and for example, a good one is that Stan always demonstrated. He would turn on a cell and produce this gas. He would produce a flame. Now, when he was doing that, Stan had some visitors from Europe. He had a Dr. Lawton and Dr. Dr. Lawton, Dr. Henley, and he also had Admiral Griffith that would show up, and they showed up at his lab one day, and I was there, and they had just visited different places in the United States and came over to see Stan and heard what he was doing, and so Stan lit this flame. Well, Dr. Lawton didn't see the flame, so he put his hand over the top of it, and Stan tried to stop him from doing that, but it was too late. He already burned his hands, and their mouths just dropped because he says, "My God, we can't see the flame." And so Dr. Henley, who was an authority on hydrogen, said, "Well, it's the purest flame I've ever seen." And if you look at a Bunsen burner or you look at the Brown's gas, you can see the different colors, the greenish and the bluish colors, which show that there's a breaking down of the molecules of the elements within that device. And Stan's device was so clear you couldn't see it. Well, if you look at Stan's video, I tell the world here, you know, that when he puts that paperclip into that flame, I want you to look at those sparklers. And those sparklers that are coming off, you'll notice that they go up a certain distance and then they split. There's symmetry in that split. What you see there is, in reality, is the plus or minus Z bosons of the atoms. And one of the scientists that came and visited Stan saw that, took a picture of it, took it back and came back and said, "Stan, do you know what you have?" And Stan says, "I don't know. What do I got?" Well, he told him what he had. And the scientists back in those days were just discovering that some of these sparklers and things are starting to show the elements within the atom. Huh. So there is a powerful amount of energy that it is evolving, and it's a relationship. And that's the point. Another point I want to make is that it's not, you break the elements down to the hydrogen and oxygen, but you know, that's not how nature works. The molecules in water actually have seven, not, there's covalent bonding, but there's also ionic bonding, and there's seven bondings to each molecule framing, if you will, if I can put it that way. But the ability of the water molecule is not like any other compound. You know, the hydrogen, oxygen, it's what I want to say. The distance between the hydrogen and oxygen is the longest distance of any compound that we have. So it has a compound condition. It's also bipolar, which means that the influence between the charges between the hydrogen and the oxygen is such that it has a charge on it. So it's very important when you start looking at the molecules. Then you have to look at everything else associated with it to understand it. And that's what I've been doing for the last 9 years since Stan passed away. In fact, he passed away this month.
Oh, yeah.
I think it was the 17th, I think it was. But in any case, I've been trying to understand what this technology is, and I think I'm at the same point that I was on the orange juice system. I look at everything that people's been doing, and by God, they're all right. The only thing is they haven't found the connection, and I think I have.
Yeah, well, I think that's certainly true that many people have obtained results without really knowing why or